Hello everyone, welcome to Clashing Coders. So in this video we will see the question 1590, that is make sum divisible by p. So this is a medium level question, but it is actually pretty much difficult as compared to the medium level question, and it is not that much light question. So before solving this question I will recommend you to solve this question first, that is sub array sum divisible by k. If you are not able to solve this question, you can see LeetCode 974. So if you are not able to solve, then you can watch my video. I will put the video link in the description, because if you solve this question then you will be having the idea to how to solve this question, because it is like 50% dependent on that particular question. So let's see the problem statement, then I will explain you how we can solve this with using some concepts. So let's see, given an array of positive integers, that is numbers array, remove the smallest sub array possibly empty such that the sum of the remaining elements is divisible by p. So it is not allowed to remove the whole array. So that means we are given a array, so we which is not divisible by the number that we are given. So we have to make it divisible by some number. So to do that, we will have to remove some part of the array. So that will be sub array. So actually you can see, return the length of the smallest sub array that we can remove, so it becomes divisible by p. If it is not possible, we will return -1. And you can see sub array is defined as contiguous blocks of the elements in the array. So that means if this is a sub array, so the array, so its sub array can be 3 1 4, or the single element, or this 4 2. It cannot be like, we cannot skip an index in between. So index should be continuous. So in this example you can see we are given a sub array, or this array, so its sum is actually 3 plus 4, so that is 7 plus this 1, so 8 and 10. So 10 is not divisible by 6. So here, to make it divisible, we will have to remove some sub array or some array from this whole array. So the element that we have to remove, the minimum length of the sub array will be 1. So here you can see, in this we will remove 4, so the remaining will be 6. So 6 is divisible by 6. So that is why we have to return 4, the minimum possible sub array that we have to remove. And in this example you can see 1 2 3, so the sum will be 6, so which is already divisible by the p, that is 3. So that means we will simply return 0. You can see possibly empty also. So if the whole array is divisible by 3, or the p that we are given, so we can simply return 0. Otherwise, in this example you can see 1 2 plus 3, so it will be 6. 6 is not divisible by 7 by doing anything. But if we remove this, it will already get more or less than 7. So that means we will simply return -1, because it is impossible. In this you can see this is divisible by 3. If we add them, so the sum is divisible by 3, so we will return 0. So from here you can see the constraints also. So constraints are pretty much large. You can see the element size can be from 1 to 10 raised to power 9. So you cannot run a brute force solution for this particular problem. So the p can also range from 1 to 9, because 10 raised to power 9. So let's see how we can solve this question. So first I will explain you some examples. So as we saw in this example, we were given, so p is 6. So in this, the simplest possible way to explain this question is actually, if you don't understand the question, so let's see, this is the array that we are given. So the total sum of this array is actually 10. So we have to make this array divisible by 6. So if you see 10 modulus 6, so if we take 10 modulus 6, so 10 modulus 6 will be actually 4 value will be left. So that means there is a array, or there are some elements which are contributing this 4 value, or the 4 remainder. So the remainder 4 is left, which is not letting this array sum get divisible by 6. So that means we have to remove the sub array which is contributing this 4 value or 4 remainder from this whole array. And here you can see the minimum is 1, because we have to remove this 4. You can see this 4. So when we take the modulus of whole sub array sum with the particular element that we are getting p, when there is a remainder, some remainder is left, so that remainder is caused by some part of array which is contributing that remainder, that is extra portion of the array. So we have to remove that portion, or we have to find the minimum length of that portion to remove. So in this array, that is 4. So now for this you can see that sum will be actually 6 plus 3, that is 9, 9 plus 2, that is 11, and so sum will be 16. Now if you take 16 is not divisible by 9, as you know that. So 16 modulus 9 will be 7. So 16 modulus 9 will be 7. So that means there is a part of some sub array, or part of this array, which is contributing this extra 7. We don't want this 7. So we have to make it divisible by 9. So to do that, we will remove the sub array which is contributing the 7. So in this you can see the sub array that is contributing the value 7 is 5 plus 2. So we have to remove this 5 plus 2. So we have to remove this 2. So the output will be 2. That is length of this sub array. You can see the output is 2 here. So we have to remove 5 and 2. So this is the simplest possible explanation of the question, but we have to do. So now let's see how can we what are the things that we need to know before solving this question. So as I explained you, we have to do that. Now if you see if let me explain you the summary of the previous question that I will provide the link in the description of that question, that is count the subarrays which is divisible by p, number of subarrays which is divisible by p. So in this example, okay, if you are trying to find a subarray which is divisible by 5 in this particular example, so how we can find that? So now if you take 5 modulus 2, what will be the 5 modulus 2? So it will 2 only, okay, it will be 2 only, so that means it is not divisible by 5. So now if you see, if we get 2 plus 2, so that is 4, sum is 4 here, but the modulus is also 4, okay, these are the modulus, these are the sum. At this point sum is 7, at this point sum is 9. So now if you see, 7 modulus 5 will be 2, 7 modulus 5 will be 2, 5 divides 7 by 1, so 2 will be left, so you can see 2. So now if you see, this 2 has again occurred here, it has occurred before also at this index, and it has occurred again, so it says something. So if this is an observation that you have to understand, this will be actually very useful, because this is solved, this is used in two sum problem and many other problems, and the previous problem also this problem was used, this particular observation was used. Now if this is a modulus, okay, this is the modulus values of the sum at the particular point. So here the sum, again the modulus is 2, the matrix is 2, so that means there is a sub array, or there is a part of this array which is divisible by 5. And you can see here the sum was 2, and here the sum was 4, and here the sum was 7. So that means there is a sub array, there is a sub array which is divisible by 2, because this 2 has again come. So that means the value that we were getting 7 modulus 5 extracted the multiples of 5 from 7, so which is 5 only. So 5 extracted its multiple, the biggest multiple of 5 from the 7, so the remaining that is left is 2 only. So that means we got a sub array which contributed to do this sum, but it got extracted by 5. That means it was divisible by 5. When you see the same remainder again, when we will have to store this remainder somewhere. So when we see the same remainder, okay, if remainder is stored before only, so that means there is a sub array which is divisible by that particular number. So to find that, we can simply do this remainders, that is particular index that we are on I, minus the index that we will store for this element. So then we will get the size of the sub array. So this is the example, or this is the observation actually that we will be using. So to store these values, we need to, as I told you, we need to store the remainders. To store the remainders, we will also have to store the indices which we have to subtract. To store them, we will use a hash map. So hash map is actually key value pair. So like this, the remainder is 2, so we will store its index, so it index is 0. Now here the remainder was 4, so we will store 4, and its index was 1. When we came here 3, so 3 plus this 4 was 7, and 7 modulus 5 was 2, so 2 is already in this array, okay, already in this map. So you got the index 0, and now here index was 0, 1 and 2, so 2 minus 0, you got the length of the sub array which is divisible by 5. You can see 2, so 2 is the length. You can see 2 plus 5 2 plus 3, that is divisible by 5. So this is what we are going to use. And also I will explain you one more property. I will explain you the more property of modulus, actually this remainder. So let's see. So if you got a value like minus 2, if you have got a remainder which is less than 2, so that what we can do is we can take the modulus of that, if to make it positive. So if we have number like 9, so okay, if we take modulus of 9, okay, minus 2 modulus 9, so we'll get value as 7. So we can make it positive, and it is similar to minus 2 plus 9. If you see minus 2 plus 9, if you have some value, like if you have some value x, okay, negative x, and if you take modulus of it with p, so we will get some value y. And if you add this value simply, minus x plus p, so we will again get that value y. So we will use this thing. So I will explain you in further in this video. We will use this concept actually. So to store this, in this example, we will have to store some keys. In this it was simple. We store the simple remainder keys. So now in this, to store the keys in the map, we can store the indices. It is easy. But to store the keys, so we have to find the keys. So to find the keys, we will use some. I will explain you. So I have found the this comment. So this is very detailed explanation you can see for this solution, and here we will see how we can find the key, or which key we will use. As I told you, this problem is based on these two problems. So I will also provide the link in the description for this comment. So you should like see it yourself, and then try to drive this on paper. So let's see. So you can see here, if the sum of whole array is divisible by p, so then we can simply return 0. That means whole sub array sum is divisible by that number, so we don't have to remove anything. We can simply return 0. Otherwise we have to do something. So as I told you, we have to, in this array, we have to remove from total sum, we have to remove the sum of the smallest sub array which is contributing that remainder that is left behind when we take the modulus of that value with p. So you can see here it is written sum of numbers whole array minus a sum of that sub array which is contributing that remainder modulus p should be equal to 0. So this is what is the equation total question about. So let's see. So now you can write it as f of I minus f of j. So f of I minus j is simply the prefix sum or the sum at that particular point. If you want to find the sum between this, okay, so here the total sum at this point is, you can see 2 plus 2 plus 2 6 plus 3, so it is 9. Now if you want to find the sum between this, so we will subtract this value, so that is I minus 1. Okay, this is I, so actually you can see this will be 2 minus 9, so that will be 7. So we will get 7 value from this. So f of I is this and f of j is this. So that is why we are doing modulus p. We can write it as this sub array sum, we can write it as this. So j is the ending index. So let's see now. So here you can see this derivation. You will understand it is not that much difficult. You can see we are simply applying the distributive law. That means this modulus p can be written for this individual values, that is a minus b can be written as this a modulus p minus b modulus p. So this is simple derivation, and at the end when we try to hold this, we will be left with this value, that is the sum at that index. Okay, for this example the sum at this index is 2, sum at this index is 4, at this index it is 7, at this index it is 9. So this is that thing, f of I modulus p, that value that we given minus the sum of the whole array modulus p, that is a mod value, or that we have left, that we have to remove from the array, whole array, to get it divisible by p. So we have to remove the extra value that we are getting. Extra value in this array is 7. So 16 modulus p, 7 is left, so we have to remove the 7. So at this this is actually the mod value that we are getting, 7, that is remaining value, and we are taking whole mod p. So because if you see we are subtracting this value, somewhere it may occur that this value at this point, okay, 2. So 2 minus 7 will be, if you see just for example 2 minus 7 will be some negative value. So we cannot show the negative value as a index, as a remainder. So we will do this mod p again. So p is actually 9 here. So if you do this, it will be a positive value. It will be simply you can write it as minus this 9 minus 5, so it will be 4, and you can try that. So let me show you. Minus 5, okay, mod 9. So let's see. So you can see it is 4. So now here you can see 4. So it is simply minus the value, any negative value, mod any number will be simply that number minus that negative value. So that is a simple observation, or the the concept that you have to understand. So this is the key that we will be using. So now here, as I told you, we have got two concepts. So we have got the remainder concept that we used to find the subarray if it is divisible, find the subarray which is divisible by 5. So if a particular remainder has occurred here and it has occurred again, so that means there was a value in between that remainder which is divisible by p. It is not divisible by p, this remainder, and this remainder is also not divisible by p, but it has occurred again. It was previously occurred. So now in between this value there was a some sub array which had contributed to the sum, but it was extracted by modulus p operation. So we have to use that concept here, and here we simply use the remainder, but here we will use this key that we have found from here. You can see this key we will be using. We will be finding this key at every step, and we will be checking if it is already in the map or hash map. If it is already in the hash map, that means we have found some sub array to remove. So we will calculate its index and we will store it to the result, minimum result, that will previous result, minimum of previous result, and that index that we are getting, okay, the length that we are getting, and we will check if that key is already there. If that key is not there, we will simply proceed to the next step, and we will add the key of the particular element that we are on, and proceed to the next element. So let's see the algorithm. So actually you can see this is the like output of the every step. So I wrote it here because it will save a lot of time. So I wrote this. So now let's see. So this is the algorithm actually. So as I told you, first we will find the sum of whole array sum, and take the mod of p, the p value, and we will check if it is already equal to 0. That means already the sum of whole array is divisible by p, so we will simply return 0. Otherwise we will perform the other steps. So that will be, you can see if this result variable that we have to return. So we will store the minimum length here, and then the sum. To find the prefix sum, actually we can simply use a variable. As I told you, at this point the sum was 2, at this point sum was 2, at this point it became 4. So we'll save the sum at that point of that point. So let's see. So here you can see this is the key that we are using. Key is equal to sum, okay, sum at that point, sum at that point, at this point sum is 6, okay, at this point sum is 6, and modulus 9 and minus mod at for this array is actually 7. As I told you here, if you see 19 is the sum, 19 mod 9 is 7, so 7 is remaining, so s contains value 7. So you sorry, this is actually mod, so this contains, this is mod, this okay. So let me actually change it. So I just corrected some name of the variables, you can see. So this is the mod, so mod will contain value as 7 for this array, okay. So mod is 7, so we will find the key at every step. We will find the key and we will check if key gets negative. As I told you, if a key or the remaining value will get negative, we will simply make it positive by adding the value divisor, the p, or we can simply take that value, so modulus with p, so it will return the same value. As I told you here, if like value is -5 and we take mod of 9 with the -5 value, so we'll return it will return 4 as output, or if we take that value -5 value, so it will be 4 again. So it will be similar thing, you can do anything. So here we will check if that key is already in the hash map that we are storing. If that key is already in the hash map, we will take the minimum of the previous result. So result is n now, so we cannot remove this, so it cannot be true. So if at end the result is remain this n, so we will return -1. As we know, we cannot remove the whole array, so we cannot remove the whole array. So here we will take the index that is stored, that is the current index. If this point key, okay, our key repeats, so we will take this index 2 minus the index where the particular key has occurred before also, so we'll take that index. So if that is 1, so the output will be 1. So this is how we are going to do it. So let's see. So now you can see at this point you can see, so after every step we will have to save the key also, key value also. So here we are storing that also. So here you can see this value. So in the map we have initialized, in the map we have initialized 0 and -1 before only. So why is this so? So we have to make a boundary before this, so you cannot save 0 here. If our like at this point, okay, our remainder gets repeated, so if it gets repeated here, 1 minus 0 will be actually 1, but we have to remove 2 values at this point. So to do that, we will save the -1 index before. So -1 index will make -1 plus, so it will become 2. So that means the length of the sub array is 2, actually 2. So at this point it repeats, so length will be 2. If you take write 0 here, so it will become 1, but we have to write it -1 to make it positive 1, then it will add up to the value. So here you can see when I is at this point, when I, let's run this and see the write run of this code. So our map is this initially. When I is at this point, our sum variable is calculated, so sum become 6, sum becomes 6, and the key will become, actually you can see key will become 6 mod p. So 6 mod p is 9, so it will be remaining 6. Then 6 minus mod 7, mod this, so 7 is the mod, so it will be -1 value. So -1, so we are not going to find -1 in the map because we are storing on the positive keys. So then we will if you can see, if key is less than 0, so yes, key is less than 0, so -1 plus 9 will be simply saved into this key. So it will be, you can see key and 9 will be added, so p is 9, so 9 will be added, it will become 8. Or you can simply take -1 mod 9, so it will be 8 again. So you can see this is the first iteration, so this is the first iteration for the first 0th index. So you can see key is 8 at this point, our map is empty. So now let's see, so we will check if this key that is 8 is in the map. So no, map does not contain any key as 8, so nothing will happen, and we will save this key. So it will be, you can see sum is 6, so 6 mod p actually is 6, so we will save 6, okay, 6 as key and that index 0 in the map. So you can see this is the first step, our map is correct. So you can see 0, -1 and 6 and 0, so that means there is no subarray till now, which we have to remove. So let's see. So now when I iterates, I comes here, okay, now our sum will become 9, 6 plus 3 is 9, and if you take 9 modulus 9, so it will be 0, so that means it is divisible. But here if you see 0 minus 7, it will be 0 minus 7, so because we are taking this minus out, so it will be -7, so it is again less than 0, so we will add 9 to it, so the key will become 2. So we will check if 2 is already in the map. So map contains 0 as a key and 6 as a key, but 2 is not there. So 2 is not there, so we will simply do nothing here, but we will save this key. So this map will contain, actually you can see s mod p. So s was at this point, s was 9, so s that is 9 modulus 9 is 0, so we will save 0, okay. So but 0 is already there, if you see 0 is already there, hash map does not contain the duplicate values. So here we will update this only, this 0 key is there. So this 0 key is there and the index at this is 1. You can see this current iteration is at first index. So this value will be updated. It will become 0 and positive 1. And this will be our map. So you can see at this point map is correct. 0 and 1 and 6 and 0. So this is actually the output of the real code that I have run. So this is the output at every step. So this is correct actually. So let's go to the next iteration. So now I will come to the next iteration at this point. So I will come here. So now our sum will become 6 plus 3, that is 9. So 9 plus 5. So it will become actually 14 because yeah, it will become 14. So now if you see 14 modulus p, that is 9, will be actually 9 minus if you see, so it will be 5 only. So 5, if you see, 5 is not in the sorry, let me check. So yeah, at this point our key will be actually not 5. So let me write it again. So you can see, so sum will be 9 plus 5, 14 at this point, and 14 minus mod is 7. So it will be 7. So our key is not less than 0. So nothing will happen. No, it will, this loop will, this condition will not be true. So we will check if 7 is already in the hash map. So it is not there. So we will do nothing. This condition will be not true. So our result is still n. So result is still this size of the array, that is 4. So nothing will happen. So now we will save this sum, that is the sum was 14 modulus p into this. So it will be 5. So 14 modulus p will be 5. So we will stay 5, and 5's index is this particular index is that we are on is 2. So nothing will happen. So now when I increment, so I will come here. So now our sum will be, you can see sum will be this 14 plus 2. 14 plus 2, that is 16. So we have got 16 as a sum, and we will subtract 7 from this. So if we subtract 7 from this, it will remain the value as 9. So 9 will be remaining. So now we will check if our key this. So you can see this at this point sum is our 16 modulus p. 16 modulus p is 7, and 7 minus modulus value, that is 7. So 7 minus 7 is 0. So that means key as at this point, at this iteration, is 0. So now you can see, yes, key is 0. This is correct. This is the last iteration. This is the last index that we are on, and we will check if this key is in the map. So yes, you can see this key is in the map. 0 is in the map already. So that means there is a sub array which is not contributing, or which we have to remove. So let's see now. This is a 0. So we are searching for the sub array that we have to remove, the minimum length sub array that we have to remove, which is actually contributing the this remainder that we don't want. We want to make the arrays divisible by this. So in this I told you we were finding if it is divisible by 5. So for that we were checking if it is not contributing, but here we are checking if it is already contributing. So we have to remove the elements which are contributing, which are not letting it divisible by 5. So in this we are doing reverse. So let's see. So now you can see the key is already there. So this loop will be this condition will be true. Key is in map. So we will take result. So result is actually for this point result is 4 only. So you can see result is n. We will take the minimum of result, and current I is 3. Current I is 3 minus the map key. Map key will be the value of that key. So it is 1. So 3 minus 1 is 2. So which is minimum out of both, 4 or 2? So output is 2. So sorry, 2 is minimum. So result is 2. So now this was our last iteration. So now it will be here in map the 7 and 3 will be saved, but that is of no use. Now we have got our output. This was the last index. So we will check at the last if our result is less than n. So if our result is less than n, then only we will print the value 2. Because if the result is n, that means if we remove whole array, then that is not possible, because it is given in this question also. In the here you can see we cannot remove the whole array. So if we have to remove whole array, then we will simply return -1. If it is not so, the result 2 is less than n. Yes, 2 is less than n. So we will return the result. So that is true. So we have got our results. And you can see for this solution, actually the time complexity will be O of n, because we are only traversing this array one time, and we are only calculating the prefix sum at that point. And the space will be O of n, because we are using this map to store this values, keys, and the values. So I hope you got this problem actually. So I will recommend you to pause this video, and I will given this output. You should run at every point, at every iteration. You should run it on paper and pen, and write on this code and try it yourself. And then you can also I will provide the link of this comment in the description. You should also try to derive this problem, actually how we got this key. So I have not explained this because it will take a lot of time, and this is easy to understand. You can understand this from here, and again do upvote this comment, because he has really done a great job telling this derivation. So let me show you the code actually now. So first I will show you the Python code. So let's see. So as you can see, first we will find the mod of the whole sum of the array. with p, and we will check if mod is already 0, we'll return 0. That means we don't have to remove anything. Otherwise we will initialize our variables and our hash map or map, you can say. Then we will this enumerate will actually, in Python it returns the index and the number or the value at that index. So we will add, so we'll find the sum, prefix sum at that point, and we will find our key. So as I told you, we will check if our key is less than 0. If it is less than 0, we'll simply add p, or you can do this step also. You can do this step also, key modulus p. So it will also return the same value. We will check if key is already in the map. If it is already in the map, it has repeated. So we will take the minimum of the result and the index, this current index minus the index that was stored here, that we have to remove, the particular remainder that we have to remove. Okay, then we will simply, if it is there, we will update our result, and at every point we will keep adding the particular value to the map, and at last we will check if result is less than n, then only we will return the result. Otherwise we will return -1, because we cannot remove whole array. So let's submit it. Then I will show you the C++ code. So I will provide the code in the description, so you can refer it from there also. So let's see. So it is also similar. You can see I have taken at every point in C++, if you try to, like, first of all add the sub arrays elements, then it will give a overflow, because this is actually 10⁻⁹. So it will be really big value, so you need to use long. So if you don't want to use long, you can simply at every point, when you add the value to particular sum, you can take mod, it's mod by p. So here we will check if it is equal to 0, return 0. Then we have initialized the map and added the value 0 and -1. Then this is actually similar. You can see at every point we are taking the modulus. Here you can see from this. So our key is this. We are finding this key. You can see at this sum, prefix sum mod p. You can see prefix sum mod p plus that number, or okay, that number. So here you can see we will check if it is less than, again, 0, then we will add it, and we will check if it is already in the map. Okay, the value or the key is already in the map, we will update our result, and then we will add that value to the map, and we will check if it is equal to, result is equal to n, then that means that is solution is not possible. We will return -1, otherwise we will return result. So this is actually a conditional operation in C++. So let's submit it. So I hope guys you got the problem. If you have not understood, you can comment down below for doubts. I will explain the doubts. I try to provide you with more sources from where you can study or understand this question. Actually, this is the question that you should try yourself, because it is not easy to explain by someone else. So you should try it on yourself, on the paper and pen, and try to find more comments like this. There are many good people which have people who have written these comments, and that really makes it easy to understand the question. So thank you for watching guys. Do like this video and subscribe the channel for more such videos. Thank you for watching.